I went to South by Southwest, and I didn't, like, there was this enormous program book. I had no idea how to decide what to go to. So I figured, let's come up with an easier way to do that. And conveniently, Cindy had sent me a link to your class website, which is over here. And then I played around in here, and I followed around to this discussion board, and and I saw, oh, there's a South by Southwest overview. So I looked in here, and okay, so you all like wrote these posts about, like all these things you're going to go to, and I said, okay, cool, I could read all that, but I don't feel like it. So instead, I wrote this script that goes through all the topics and picks out all the links and saves all the links, and that results in all these tables here. I'll explain more about this interface later, but the point is, so we went through all these topics, and we found all these links to all these panels, and then I could do things like say, who wrote about the same links? Well, actually, first, before they do that, who posted? How many links did people post? Just to start here, just to see the basic thing, So here we have all your names. Well, not all fit on this page because there are more than 10, but here are your names, and here are how many links you posted. Okay, that's cool.
Everybody's like, whoa.
Yeah. So actually, yeah, that itself, like, if this were a larger class, it might be more interesting, but it seemed like there's this cutoff at 4 or 5, and then people go up after that. So I thought maybe there was like a requirement in the assignment that you had to do 4 or 5 or something. Maybe not. But here's the thing that's more relevant to me, and that's all I care about. So I wanted to say, like, which panel should I go to? Well, so I said, maybe if multiple people posted the same panel, it's worth going to. It turns out, like, there weren't very many where people posted very many of, but still, like, I found, so sometimes people posted people have posted twice, and so that's why, like, here Megan's name comes up multiple times at the top. But I looked through here and I found a few where, like, Sean, Kiana, and Sarah all posted about this one. So I tried to go to these, and it turned out, like, various reasons I couldn't make very many of them. But anyway, the point is, like, this is I can use a scraper. It's just like, this is the way I do things. Automate some redundant task or repetitive task with a scraper, and anything can be, like, turned into data. This is just like a web forum, which is actually powered by a database in the back end. So, but even if it weren't, we can pull out the raw blob of text of the page and figure out something from it. And actually, if the class were larger, I would have felt more interested in doing some Brazier stuff. But like looking through it, I saw some cool things, like in your introductions, some interesting trends about, like, some people seem to be talking about this sort of thing, and I was curious, like, what proportion of people talk about this thing. So that's another thing that, you could write a scraper to do this, and then you could do some natural language processing to figure more stuff out. So anyway, this is one example of things that you can do with scraping. And I heard, talking to some of you at the taco party, that this sort of startled you a little bit. So another thing to think about here is when you're scraping someone's website, you might be thinking the same thing. Anyway, let's get down to the main stuff. So let's see. If you go to this page, or so actually, yeah. So this is actually the same talk I give at NICAR. So, like, there are people at NICAR who don't know this stuff yet. You're like, this is new stuff. I mean, to journalists at least. So yeah. So the first thing is, this page has, if I were taking notes, this is the only thing I would write down, actually, the link to this page, which has this rough outline that I'm going to use, and it has this cheat sheet of code so that you can refer to it later, and it has links to the slides. So it's sw.thomaslevine.com. And yeah, when we get to the computers, you'll want to open that up later. But we don't need to do that just yet. So what we're going to do today is, first we're going to have sort of an overview of what scraping is, how to think about scraping. Then we're going to talk about Scraper Wiki, which is not the only way you can write scrapers, but it's helpful in this case. And then third, we're going to scrape this particular website, and that's going to be the majority of the session. And then we're going to do some basic analysis of the data that's been scraped. So So one way to think of, or we can think of web scraping as having 3 phases. I mean, it's sort of a lie to tell you that it's actually 3 phases, but first thing you might want to do is look at the website and understand the website, see whether it's worth scraping. This may be something you wouldn't actually want to think of as one of the steps, but you'll see why it's actually like worth thinking a lot about. Next, you're going to you have to get to some page that has the main data you want, and then you're going to parse it. Although these 2 steps get muddled. So first, for finding it. So you go to a web page and you might find data, but there are going to be multiple ways of getting to the data. Like maybe you missed the download as a spreadsheet file. So before you start like trying to scrape it, look for something like that, or maybe there's an API or something. Now, if there is an API or a spreadsheet, you don't necessarily have to use it. It might not be easier, but think about all the different ways you can parse it. And then, but anyway, to figure out whether it's actually worth writing a program rather than doing it yourself, one good metric sort of is if you think you'll get very bored just scraping it or manually going through it by hand, then it's probably good to write a program to do. Because if it's very boring, then it's probably very stupid, and it's something that a computer could do very easily. But if it's very challenging and exciting, then it's probably something hard to program a computer to do. So that's the planning stage. Remember, we have these three stages. So the next part, I actually don't quite like calling this word, but Julian, who's another person scraping, likes calling this scraping. So you need to go through all these pages and get to like the main page you're interested in and download it. But this can be hard because you have to understand, like, not all web pages you can just put in a URL and get to it. You might have to know something crazy about HTTP requests, although a lot of cases you don't. But so once you've gotten to the main page you want, which is actually just an HTML page, normally like a text file or something, then you have to figure out how to parse it, which can be complicated sometimes. One thing that you all have to also consider is how you're going to store the information, particularly if you're going to run it multiple times. Sometimes it's very helpful. You can come up with something that's a unique identifier, but not necessarily all the time. Anyway, this is all very abstract, so we'll get to something more concrete now. So one like very basic use case for like writing a web scraper is maybe you have something that doesn't stay up and you want to keep a record of it. So even just like downloading a web page and just keeping the raw file can be very helpful. In this case, the New York City Police Department every week releases this very fancy statistics something that they say is very helpful. It's this PDF that tells them like how many murders, rapes, robberies, whatever there were in the past week, and then they have all these numbers that are really just aggregates of other information. So this is like very useless on its own, but if we were to collect it over time every week, it'd be useful. The problem is they take it down every week. They only keep the last week. So here's one place where like a very basic, just download this PDF every week and parse it can be very helpful. And yeah, so someone actually wrote a scraper for this on Scraper Wiki a couple of years ago. So now we have this table. This information can actually do something with it. Yeah. And then in this slide sheet, there's more information that we'll get into. Okay, so that's like a very rough overview of scraping, but let's get on to Scraper Wiki now, and then we'll get onto the code. So you can go to, I guess you can go to the computers now. You can go to scraperwiki.com. You review your Python before, it's sort of the same thing. So where are the slides? Yeah, so the first thing we're going to do is we're going to write a Hello World program. I suspect you've written one of these before, but so let's see. So you go to the actually before I do that. So in general, like if you want to write a scraper on Scraper Wiki, you can just go to the home page and click this create a scraper button. But for this session, I want you to follow along with me. So you're going to go to the so instead, don't click that button, or you can do it, but like we're not going to. It's better if you follow along with me by going to this sw.thomaslevine.com.
So should we open a new window for that?
Yeah. So when you when you get here, it'll look like this. And I use the same page for Python and Ruby, so you have to click the Ruby button to switch to Ruby, because we're going to do Ruby today. And then if you scroll down a little bit, it has a link to the Ruby scraper page, which I suppose I could have put more prominently. But click that, and then you'll all get put into this session here. You should all start popping up here, and you'll be able to follow along with me.
Do we make our own copy or just?
Just go in. Just click. Oh yeah, sorry. Click edit. Oh no, it'll put you in the edit page, right? Yeah. So you should all be able to see what I do. Right?
Yeah.
Okay. Good. Yeah.
That's pretty cool.
That's pretty cool.
Yeah. So. Oh yeah, and then at some point during the session, I'll tell you to like try play with on your own, and then you'll click the copy button and play with it, and then we'll come back. So yeah. So first. We're gonna write a Hello World program. So I suspect some people actually know how to do this already. Does anyone want to tell me what I write?
Puts hello world?
Yes, yes.
Yeah.
Yeah. So that's just gonna print that into the console. And if I were running this on like another system, it would come out to terminal, but here it comes out to this console window down here. Let me make that bigger. Yeah, so it comes out to here, and there we go, hello world. And you can also see it on your computer. So this is nothing different from what you do on your own computer, but it's in the browser, and it's running on ScraperWiki server, it's not running on your computer. So that's the first thing. Yeah, so we just wrote a Hello World program on ScraperWiki, or I did, if you watched it. So the next thing we're going to do is we're going to use ScraperWiki's data store API, which allows you to make an SQL database without really knowing SQL. So first, actually the code for that and the Hello World is on here, but you can just follow along with me. Well, I'll cheat and copy and paste it.
You do that a lot.
Yeah. Just to save time. So the way it works is so ScraperWiki has this. Let me do this properly. I'll try now. So we need to use the ScraperWiki library for this. So we're going to require ScraperWiki. And then we can use the ScraperWiki save function. And we're going to give it, well, it takes at least 2 parameters. The first one, don't worry about for now. Just pass it an empty list. And the second one, I'm going to call it data, and then I'm going to define it above. But this is the function that's going to put things into the database. Now, data, like, I didn't define it yet, but it's going to be a dictionary, or you might also call it an associative array, or a hash, or whatever. So now I'm going to choose basic, so I don't have to type so much. Yeah. So here's that data dictionary. So it's like this is the structure of a dictionary is you have a bunch of keys, each one has a value, and so the way when this gets put into the database, these keys are going to be column names, and these are going to be values in the column. So when we do this scraperwiki.save, we're going to put this into the ScraperWiki database. So let's run that. And so, okay, we didn't print anything new, so we still say hello world. This data tab pops up and says that, which isn't very useful. But we can go to the, if you click, it disappeared on mine because I zoomed in too much. But you click, go to the overview or something like that in the top right corner.
Scraper overview.
Yeah. Then you can see there's this table here. And that's the information we just put in. So, yeah. So how about we can take, let's say like 1 minute, and you can copy the scraper and try just changing that dictionary and putting something else in there. Okay, so the next thing. So we did a Hello World program, and then we used the Scraper Wiki database API. You could have used standard SQL. This is just an easier way of doing it. And then now we're going to download a web page. And these are like 3 sort of fundamental things, and then we'll go on to the main scraper. So
and when he said standard SQL, we did the SQL manager, SQLite manager, and we did the different queries with insert and select. So that's what he's talking about. Like we inserted data into this data store.
Yeah, and we'll use some SQL later to do the analysis. Yeah. So now just some basic downloading a web page. That's what we're going to do. So to in Ruby, we're going to use this library OpenURI, and that's going to allow us to do something like this. So let's say we're going to make a new variable called download, and we'll say open some URL. How about .com? Is that it? Mm-hmm. Okay.
Oh wow, that's great.
So actually, let's do this.
What you're gonna get off of that?
Can we copy this also?
Oh, so this, I mean, anytime, like, you can feel free to copy it and play with it, if, like, you're getting bored of what I'm doing or whatever. But I'll tell you when I want you to, like, do something.
Okay.
Yeah, but it's, feel free to copy it and play around with it if you have a little thing you're wondering about.
And then that pound sign is a comment, right?
Oh, yes.
So you guys know, like, when we have comments in certain types of programs in Ruby, the pound sign indicates that this is a comment line.
Yeah, so I guess I'm not necessarily assuming that like, even if you don't really know Ruby, like, I think it's helpful for you to see this and, like, get a feel for what can be done. And even if you don't actually do this, it's like, understand that this isn't really magic, that it's like, if you find someone who knows computers, that you can get someone to write a scraper or whatever. And then maybe you go off and do it later. But if, so I wouldn't worry too much about if something about the syntax is, like, you're confused about. But if there is something, like, that you are really confused about, please say it. Yeah, so anyway, here what we have is, well, what we're doing now, I deleted everything else. We're just opening this and we're going to print that download thing. And it's not going to be what you expect probably. So, yeah, so I ran it, and when I did puts download, it printed this like string IO 0x000. That's because download is this fancy object that has a lot of information about it, and that's just a memory address actually. So that's not very useful to us. So what we want to do is download.read, which gives us the HTML code of that web page. So I ran it again, and then now we see at the bottom this thing that starts with doc type HTML, blah, 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 blah. And in Scraper Wiki, if it's a very long thing that gets printed out, you click more here, and then you can see the whole thing.
That's my web page.
Yeah, so you could also do this by like going to the web page in the browser and clicking view source or something like that.
You can also do that.
Yeah, but the point here is we download that web page onto Scraper Wiki server and then printed it. And so now we can do something with this text. And that's what we'll do. We'll do that when we start the main scraper. But anyway.
Question?
Yeah.
When you did puts download the first time, you were just showing us. You don't have to do both of those steps.
Oh, right.
You were just showing us the difference.
Right.
You just
Very good.
commented them
Very
out.
good.
Right.
Right.
Making sure.
Yeah, and if you're doing this on like not on Scraper Wiki, if I were doing this on like a console, every time you type out download, it'll just show that. The reason I do, does it make sense to you? Like, have you used a console before for?
We haven't yet.
Oh, okay.
In this class, I have, but we haven't yet. But
Okay.
we will.
Okay, then, well, if you haven't used a console, ignore this next sentence. But if you have, the reason I'm saying print everywhere is just that I don't have a console here. Yeah. So we
And
just
then, like when we did the JavaScript stuff, I had commented things out that weren't happening, and then recommenting something else. So that's exactly what he was just doing.
So we did a hello world program, then we used the database, and then we downloaded the web page. So now we sort of have a few building blocks that we can make a scraper with, but there are more, and I'll tell you about them. So we're going to scrape this collective bargaining agreements website. It has all the agreements I think it's all the agreements that have to do with, all the agreements in the United States that involve more than 1,000 workers. And it has been divided into divided into public and private. So let's look at that page first. So this is like the first page you get to. Has like links to these sections of the alphabet. And if you click on one of them, you get to something like this, which has a listing for each agreement. And so if I know the employer name, I can get to this page where I can look up the employer name and say CBI Services has, like, it's in Alabama, the union is BDF, that's some special code, and that's the number of workers. And then if I want, I can click on this PDF link over here, and I can get to a PDF file that's, well, here it is. It's actually something that we could sort of parse. It's not very standardized, but maybe we could do some language processing on it. Maybe that'd be cool. Anyway, so that's the whole site. So let's get back to the slides. So when I do scrapers, I break them into different page types, and I sort of write a function for each page type in a sense. So the first page type is that main page that lists all of the alphabet ranges. The next one is each of those ranges has a table. And then after that, each table has a PDF file. And so for each one of these, we're going to have to download the web page, and then we're going to have to parse it. So for this one, we're going to download it. We're going to extract the URLs, the links to all the agreements. And then we're going to visit each of those here. And we're going to extract all the information there, and we're also going to extract the links to the PDFs. And we could download those if we wanted to do the whole site.
And this is similar to that, the Texas Music Office site I showed you that had like the A, B, C, D across the top. And you would scrape that site in a similar manner. It didn't have links to PDFs, but it did have links to websites and things like that. So.
Yeah, this is like anything that's more than one page. It's probably going to be, you're going to need a way of figuring out all the pages to visit, and then visiting all of them. And they might give you links to more pages.
It's amazing how many sites use that method of navigation of here's the A's, here's the B's, and no other way to like search or
right.
sort. Or
and that's why we want to scrape it.
Right.
Yeah, because we can't. Well, you'll see. Yeah. There are a lot of things we can do with the data once we scrape it. So there I said 3 page types. We're going to start with one of them because actually sort of the most fun and easiest one. Just the table page. That's, to remind you, that's the page that looks like this. Yeah. So first, here's the table. We're just going to, instead of downloading Cindy's site, we're going to download this particular site. And then I'm just going to print the source code of that. And yeah, here it is. So this is the source code for this page. And we need to find where this table is inside the source code so that we can parse it. So we can start by just like looking through the source code and trying to find it.
We all know what a table looks like, right? In HTML, right?
Yeah. And so normally I'll just search for the something that's inside the table. So we can go here and we can search for CBI. Okay, we can search for CBI services, and there we go. But it's inside this big mess of stuff. But we can go up and find stuff. But actually, that's annoying. So let's do it a different way. So yeah. So even though you've surely covered this in Cindy's class before, the other one, let's just go over what a table is like. So this is just a section of the table. But if this were the whole table, we'd have a table inside that. We'd have TRs inside that. We'd have TDs. In this particular one, there's no T-body and T-head elements, and also there are p tags inside each of the cells. So the first thing we're going to do is we're going to look for the table. Yeah. So to do that, eventually we're going to use CSS to find the table. But first we need to put it into a special object that can understand CSS, because currently it's just this blob of text that we can't pretty much with. So we're going to use this library called Nokogiri. And let's see. And instead of, let's say, I think that's it. Sheet here. Make sure I have this. Okay. This is okay. Oh, okay. Okay. I normally use the Python, a different library to do this, and so it's a bit different for me. So to load this into Nokogiri, we take this, we run Nokogiri HTML on this special download object, and that gives us this thing, which when we print it, it looks like the same text, but it's actually a much more complex object that allows us to run a lot of things, including CSS selectors on it. So now that we have this, we can so now we have all this HTML in a form where we can run CSS selectors on it. And if I put a CSS selector inside of this double quotes, or inside this quotes here, I can search for it. So what do I mean when I say a CSS selector? If I wanted to make the text inside of a table blue, what would I write in the CSS?
Color colon blue. Semicolon.
Right, but what if I want? So you're saying color blue, right?
Yeah.
But I want it only to be inside tables.
Oh, so table.
Right. Correct. Right. So
And if you only want that inside the cell, I guess you want all of it, so it doesn't matter whether it's in rows or the.
yeah, right. So the point here is the stuff inside the brackets or the curly braces is the style, and we don't care about that right now because we're just selecting things. The stuff before it is the selector, and like it could also be more complex, of course. Table inside of a div of some sort, So, so what we're going to put in here, we're going to select all of the tables first. So, what do I write in here? Yes, table. It's an easy one. And then let's just print it. Oh, I didn't. Yeah. So now what it's doing here is it's actually a list, but Scraper Wiki's printing it as 3 lines. So it's printing these 3 tables, and these are actually special Nokogiri objects. They're just printing as source code. But now we have 3 tables here, and we want to find just one of them. So I'd like everyone to you might need to copy this, but you can copy the scraper and try to figure out which of these tables is the one we want.
Yep.
Yeah. So if you haven't found it yet, don't worry. There are 3 tables. Who thinks it's the first? Who thinks it's the second? Who thinks it's the third? Great. Okay. And the other 2 tables were blasphemy nowadays,
Yeah,
but it's
don't
when
use that.
yes.
Don't use tables for those things.
Don't use tables for
Okay.
formatting. Yeah, for that. Okay. But government web pages that have not been edited in a long time. Yeah.
Right.
So yeah. So we want to select the third table. Tables is a list. So even if you haven't used Ruby, guesses as to how I would select the third table? It's actually table 2. Yeah.
Yeah, because 0, 1, 2.
Yeah.
And we haven't done too much yet with the programming, but when you do count in many programming languages, it starts with 0.
Yeah.
So the first item in the list is 0, 1, 2, or the array, or whatever. We'll talk about that.
Yeah. So now we've selected the table. We're going to go back to the libraries because I realize you don't quite understand that, or haven't talked about that much. So these ScraperWiki, OpenURI, and Nokogiri are all like just more Ruby code that someone wrote, and they're sitting on a file somewhere, and I could just like copy them and paste them into this file, but that would be silly. So instead, there's this feature where you can just write require, and it'll just load all those, so you don't have to copy them.
And so just by saying require, it'll find them because these are libraries on ScraperWiki.
Right.
Is there a listing of these libraries and what they do somewhere?
Yeah. So, well, these three. Well, sorry, these two. So ScraperWiki is only available on ScraperWiki, and actually we're working to make it available off of ScraperWiki. So for now, you can only use ScraperWiki on ScraperWiki, but the other two are just standard libraries that you could install with Ruby gems or whatever. So
And like the names, like Nokogiri, is there some significance to why it's called that, or does
Probably.
it mean something?
Okay.
Because I mean, sometimes if you know what it means, it helps you remember it. So
I don't know what it means.
I know I've seen it a zillion times, and I still don't know what it means.
I can tell you OpenURI is, well, as you're opening, I don't know what URI stands for, but it's
Uniform
like,
resource and uniform resource.
well, a URL is a type of URI.
Yeah.
That's,
Yeah.
that's what I remember.
You know.
So it's for opening things like that.
So that one makes sense.
Yeah.
Nokogiri doesn't make sense to me, but I'm sure it makes sense to somebody.
Yeah, well, so let me say, if you just use open without that, I think, you could also open a file, and this acts very similar to the way you would open a file that's on your own computer. The way you have to do download.read.
But Nokogiri, like the purpose of it, forget the name, is doing certain things with HTML.
Yeah, Nokogiri is for XML in general, and HTML is sort of a type of XML. So I guess we can look at this because we're.
It's a saw.
It's a song. Okay.
A saw,
A saw.
like for woodworking.
Ah, yeah. Okay. Oh, is it?
So it must be cutting up code.
Yeah, sure.
Okay, now we know.
Yeah. Like,
But it's Japanese, though. I guess that makes sense. Ruby's
Yeah.
written by a Japanese man.
yeah. Okay. Well, anyway, back to this. So now we've found the table that we want. Let's assign that to a variable called table. Now the variable names don't matter at all. I tend to name them after the tags. Like when I'm doing the scraping, I tend to name them after the HTML tags, so I don't remember them. But you could name them whatever you want. Yeah, so now this table that I have here is this table, and that's the table and that's this table, the table on the web page. And so now we want to, we're going to want to go through each of the rows, then we're going to go through each of the cells and extract the information from it. So let's go back to how a table is structured over here. We have the table tag, and inside that we have the TR tags. Inside that we have TH or TD tags. So we're going to use CSS again to select the rows. So normally when you do, if I were to run if I wanted to say all the table rows should have like green text, I could write a CSS. I could write CSS that would say like TR. I could do this, and this would get me all the table rows on the page. Does that make sense?
Yeah.
Okay, so if I just replace this table with that, I would get all the table rows on the page. We don't want that. We want only the table rows inside the current table. So with Nokogiri, we can do we can do the same. We can instead of putting it up here, we can do it in here. So we're looking for the table rows within the current table, and here's sort of a diagram of that.
And that's because he named that tables two. He named it table
Yeah.
as the variable name.
Right. So, like, here's sort of a diagram of it. CSS select is just a different library's way of doing it. But so if the first time we select this particular table, and then when we run search on this table, we get the table rows, but only the ones from this table. So I've just said the same thing multiple times. But now let's run it. So yeah. So now here we're selecting that table, and then we're searching for all the table rows inside it, and here we get this big mess of all the table rows. And I mean, we could have just copied this, but the new thing is that they're actually a list, and they're all separate elements in the list. So, for example, we can just say now, let's just choose one of these rows. Well, let's make it a list, and then I don't know, let's take the 7th one.
So again, he's giving that search a variable name so that he can find one of the items in it. The 6th, well, actually the 7th item.
Yeah. So now here I picked out the 7th table row, and that's the 7th table row, which is like I could have just copied and pasted this, but yeah. So now I have it all in a list, and I can just select the 7th table row. So let's go back to the page that we're scraping. So now we've selected the table, like the whole table, and then we've separated it out into table rows. And then we've gone down to the 7th table row, so 1, 2, 3, 4, 5, 6, 7, and this one. So California Plumbing and Mechanical Contractors, and indeed that's the one we have. Okay, now we need to go down further. We need to go down to the table cells. So, so now let's, I'll just say, let's call this one TR. And then if I want to find the table cells inside of that TR, I'm going to write another CSS selector. And what do I put in here?
TD.
Yeah, TD. So now, same thing before, we're selecting that one table row, and now we're just going to print the TDs separately. And there they are. Okay, and then these are still they have these tags in them, and we don't really care about the tags. We just want the text inside them for most of them. So we want, so let's, well, yeah, so now let's do that. So let's just take one of them for now. Let's take, I don't know, the first one. And that's it. Yeah, okay. So then if we use this, if we do this text method, it just pulls out the plain text of that cell. And it gets rid of the tags, and also if it had a link in it, it would remove it would not tell you that it's a link anymore. It would just give you the text of the link. So,
everything that's not a tag.
Right.
Yeah.
Now sometimes it's unpredictable if it has like VRs, but yeah. So that's that. So now,
did everybody get that?
yeah.
I don't know if everybody was able to follow along. Do you want everybody to be able to like make sure they get that, or do you want to move on from there?
Well, let me go through it again,
Okay.
and then I think after this I'll have you try it.
Okay.
Sort of. So yeah, we selected this table, this whole table, and then we selected the 7th row of this table, and then we selected the first cell in that row, and then we pulled out the plain text of it.
Yeah.
So now we could, we could do other things with that plain text, like we could say cut off after the 10th character or something like that. We're eventually going to want to put this into the database, so we're going to want to loop among all the, we're going to want to do this for more than just one cell. So let's see. Have you done loops of some sort?
Not really yet.
Okay.
We will. Not
Okay.
really yet.
So let's see. So let's do a loop that's not like anything to do with this, just to write a loop. First let's make a list.
Did we do any kind of loop? I feel like I showed you something that had a loop in it. Didn't I show something with some of the SQL stuff, or maybe something in the JavaScript? If not, we'll definitely do loops.
Okay. So here's a loop down here. If I wrote it correctly, it'll okay. So this is a list. The things that we have are lists as well. We could represent them in the structure, but they get printed differently. That's something I think we should change. So then here it's going to visit each of these elements, and it's going to print that element. What I was doing before is I was not looping it. Instead, I was doing, I'm just commenting this out. So before, what I was doing is saying, let's not deal with loops yet. Let's just say person is just the second element. Let's do this one so it's like the first element. And then I was just selecting the first element of this list and printing that.
When you had it as a loop and you called it a person, you were declaring it as you were using it.
Right, yeah.
Okay. All right.
Yeah. I just named them the same thing so that, I've been naming them the same thing so that I'll be able to easily turn them into loops later, actually. So the next thing we're going to do is turn everything where I've been selecting just one element in the list to turn that into loops over the whole list.
Because what he's going to want to do is go through every line of that table and pull out the information. And in this case, he's just using the example of a two-person list. So it's got to go through the loop each time.
Yeah, so first, instead of just choosing one TD, we're going to say for each of these TDs, we're going to print the text. So before we were just printing the first one. Here we're going to print each of them. Oops. Oh, right. No colon. Yeah, and then there you can see that. You might be able to see it better on your own screen. But
Does indents don't matter in Ruby, right?
indents,
No,
the
space.
number of indents, like the number of spaces doesn't matter, but indentation, does it?
Python
It does.
Python it does. I don't
space
think it does in
independent.
Ruby.
Oh, really? Okay.
I could be wrong, but I know it is in Python.
Well, even if it doesn't matter, I'm going to make it look nice. So,
Right.
yeah.
But I just,
Well, let's actually wait. In general, the answer with this is try it and see if it breaks.
right.
Cool. Okay, and it doesn't matter. Yeah. So, yeah. So we went to the, like again, what we did, we selected this table. We went to the 7th line of this table, or the 7th row, and before we were just taking the first element, but now we're printing each of these cells. Yeah, we're printing the whole list. So now we can, you can copy the scraper again and try to, here I'm just selecting the 7th table row. Now try to loop among all the table rows. So you're just going to add another loop outside of this one. Does that sound daunting? Maybe. Okay, okay. I'll just do it then.
Say it again.
So, Yeah, I'll just do it. I'll just do it.
Well, say it again,
I mean,
what you're doing, so then we can kind of follow what you're
Yeah.
doing.
So previously, we had said like TD equals like TD's something, and then we just printed that one, and then we switched it to we're going to go through all the TDs, and we're going to print that, and then I just moved that code in here. So here I'll just outline the loop, and then I'll let you finish it. So instead of selecting one table row here, you're going to do something else. So and yeah, and you need to figure out, you need to finish this line. Yeah. I'm just going to delete this line. And then it looked like some of you knew the answer, so I'm going to get rid of this, and I'm going to put something here. So who knows what I put here?
Yes.
Great! Oh, yes, okay. So now if I run this, we'll have a lot of junk get printed out, and it'll take forever. So there we go. So now each of these lines is the table cell inside the table row inside the table. So like we're going through each of these rows, and the first line that gets printed is, well, it's actually this one, and then this one, and then this one, and then this one, and then all through here. And now we have we're just printing a dump of all the cells separately. Yeah.
Do you need to put tr.text?
Let's try it.
I did that.
You did it.
Yeah,
Okay.
we just did that.
Okay. So what did you see when you did that?
An error.
It also spits out a ton of.
Yeah. But so when it does that, here I'll do it.
Oh, I got an error.
So I'm just gonna I'm not gonna do the. I'm getting rid of everything. I'm just gonna do the puts tr.text, and then I'll show you what happens. Yeah. So here it reads each of these as a separate. They're inside p tags, so it reads them each as a separate paragraph, and then prints each of the cells in a separate line. But here, these are just, the structure is just, it's a blob of text that happens to have line breaks in it. It's not as separate elements in a list. So this actually would be fine to us because we could just parse this again, but it's less useful less useful to us than the other format is. But what this is doing is it's just stripping out all the XML information from the TR tag and printing it as plain text. So now we went through all the table rows, we went through all the table cells, we printed that. But this is just giving us each cell separately. And that's not as useful to us because we want to put it in one row at a time. So let's remember the scraperwiki.save function. Here. Yeah, so remember at the beginning when we used the scraperwiki.save function, it takes a dictionary that represents the whole row. And so we need to get information grouped by rows rather than as individual cells. So, so instead of just, in this loop, instead of separating them out in this loop, we're going to keep them as a list. And we're going to use a map, or like a Ruby block, which this is like the most fancy thing that I'm going to do, so it's really, don't worry too much if this doesn't make sense. But I'll try to explain how it works. So, I need to remember too. Yes, okay. So TDs is a list, and we're going to make another list that is sort of a transformation of it. I think this does it. going to do just the first, like, the first few rows. This is what I did up here. This just selects the first 4 elements of the, or 3 elements of the list. And let me make this here. So it's like sort of confusing that like they're printing on separate lines, but I want to show you that they're all they're separated by that they're all grouped by row. So just to show you that, here what I did is what I did is, don't worry too much about this. I turn this list into a list of the cell contents, the plain text, and then I'm just going to each element in that list is like letters. I'm going to put them together, separated by commas, just so you can see it. And so now each of these lines is a separate row. So this one, C&D Security Management Incorporated, it came from down here, or no? Yeah, okay, so it came from here, so we found the table, we went through the first few rows, we picked out this one, and then we went through all the cells, and we took out the plain text, and we joined it together by commas. So now we have it at, like, we have the data grouped by rows, but we need to get it into a dictionary so that we can put it into the save function. So let's not worry about that. So in order to do this, we're going to need the column names as well. So normally I would actually take it from the page, but this particular website is sort of inconsistent about the way it names columns. So instead we're just going to hard code it. And I conveniently save that in this file, in the sw.thomasgreen.com notes. So that's this. So I'll just put that at the top. So I'm going to call this list column names, and it has one element for each row in the table. I name it capital column names rather than lowercase because it's sort of convention that constants are named capital letters. Yeah. So right. So actually, I have this page. So these are the column names, and we might have a row that looks like this, and we want to turn it into a dictionary like this. So the first element of the row is going to be it's going to say employer arrow California processors, download arrow not available, local arrow that, I guess. And look it on the original page. It'll be like, the reason is, it's going to say employer name arrow that, like NAICS arrow that. That's what we want to do. So the way we do that, currently we have the row content, like we have the values of the cell. We need the column names. So it's, well, first, this is going to, okay. so it's knowing that the way it's printing, it's not showing you the structure of it. But what this is doing is it's saying we currently have these two lists as we have currently the lists look like this. They each have 8 elements, and we want them to look. We eventually want them to look like that, but as an intermediate step, we want them to look like this. So I'm just going to do it for like 2 of them so that you can see it. We wanted to say so before it was 2 long lists, and now it's going to be 1 list that contains lists. So the original lists were like this list and this list, and they each have 8. Instead, it's going to be 1 list of 8 elements, but each element is going to be another list that's going to have 2 elements.
And it's always, the first one is always, you're going to be repeating employer each time?
Right, yeah. So for each row is going to have a list of this sort, and the second element is going to be different, and the first element is always going to be from here. And the order is always going to stay the same. And so that structure that I just deleted is what I created over here. I got it. Yeah. That structure is what I created over here. And this is still not a dictionary. So to make it a dictionary, we use this, we write hash there, and then it turns it into a dictionary. And now it prints in a way that you can see it, so that's better. And yeah, so this is the structure that we're going to be able to put into the square repeating function. So like I am repeating myself a lot, but we went to the table, we picked out a row, and we combined our hard-coded table or column names with the row values based on the order, and then we got this dictionary. And then, oh, actually, I got it backwards. Sorry. See, employer is the value here, and so I need to fix that. But otherwise, it's right. So let me just fix that. Yeah. So here, the way this works is, I did values.zip column names. I should have did column names.zip values. Okay, that looks better. So now I'll put this into the database, and then we can look at that.
So we need to take a break at a point.
Okay.
So find a good breaking point.
Okay. Let's see. So we've done. Oh, so it's right about halfway now. So how about we'll put this into the database, and then we'll take a break.
Okay.
So let's call this data, and so this data is for 1 row only. We'll do scraper wiki. I don't know this calculation. Okay. There you go. So now, yeah, we only went through the first 2 rows, but we went through the first 2 rows. We zipped up the information, put it into a dictionary, put it into a scraper wiki save function, and now we can go to I don't have it here because I'm zoomed in so much, but we can click on that link and then we can see the table of all this information. And that's here. And here we go.